Hello everyone. My name is Tezpur, a sixth semester student of Mechanical Engineering Department in Tezpur University. Today, a problem is assigned to me as a task for the course of Computer Aided Engineering. It is a problem for our end semester examination. So, problem is like that: modeling and finite element analysis of a torsional shaft having circular cross section using a suitable software package. A description is also given that you can choose the relevant dimension of torsional shaft as per convenience, and for the basic understanding or diagram is also given. For the modeling and analysis purpose, I will choose ANSYS because it is suitable for both modeling and analysis purpose. So let's start with ANSYS workbench. Since this is problem related to static structural, so simply we click on static structural. There are several steps, basically seven steps. The first option is engineering data. In this option, basically we can select the material type and the property related to the material. But in the question, there is no mention about any specific data regarding the material type and density and other factors. So we simply go through the default setting, which is structural steel. So simply delete it. And the next step is geometry selection. So the shaft is basically a cylinder fixed at one end. Okay. Simply click on a XY plane. Okay. So to draw a cylinder, first we draw a circle centering from origin. Then I will give a dimension, a diameter of, let's say, 0.1 meter. Okay, zoom it. So it will look like. Then I simply extrude it to form a cylinder. So extrude it, select the geometry and apply extrude. Okay, give the depth of, let's say, 1 meter and generate the shaft. So our shaft is ready. Then this is done with our geometry part. Next step is model. So simply click it or right click in the select model. It will take some time to upload it. Okay. So this is our shaft. Firstly, we generate a free mesh. Since mesh is not so fine, so we will add element size to refine the mesh. Let's give the element size like 0.02 and then generate mesh. Okay, mesh is ready. Although I will insert the refinement to refine the mesh, select the faces. After refinement, the mesh will look so smooth. So generate mesh. So our mesh is ready. Okay. In the problem, the shaft is fixed at one end and a torsion is applied to the other edge and also a force is applied to the extreme end. So give it the all constraint in static structure. Simply insert a fixed support. So it is asking for a geometry selection. So let's select a face for fixed support and then apply. So the face in the positive direction, it is fixed support and then insert a moment and select the edge. Okay, and then apply. So the moment is applied on the edge. It is defined by vector, so we change it to vector to component form and then give it the magnitude of, let's say, 30 Newton meter, minus 30 Newton meter. So you can see that the direction of the moment is anti-clockwise direction as shown in the problem. Okay, now I will insert a force, basically axial force, in the extreme right direction. Yeah, extreme right face apply. And again, change it to from vector to component form and give it the direction in the negative z direction, which is about one, let's say minus one Newton meter. Sorry, Newton. Forces in the Newton. So it will look like. So the fixed support at the positive z direction, a moment in the extreme right edge in the anti-clockwise direction, and a force, axial force in the positive z direction. So this is done about the modeling part. So next, calculate for the solution. So basically, we will calculate for total deformation, equivalent stress, or we can say von Mises stress, CS stress distribution, and equivalent strain. So let's add all the constraint, so all the parameters, the deformation, total deformation, edit, insert, stress is equivalent to stress, and stress again equivalent stress, and deformation we can take directional deformation. So we are calculating for total deformation, equivalent elastic strain, equivalent stress, and directional deformation. So give it command to solve it for the four parameters. It will take some time. Okay, okay. So this is total deformation. Let's play it. So it will look like that. At the fixed support, there is minimum, or we can say zero deformation. And at the right extreme face, the maximum deformation will occur. Same for the equivalent elastic strain at the free end, sorry, at the fixed end, the deformation will be minimum. We can say strain is minimum, and the right extreme face, strain will be maximum. And equivalent stress, same. It will show the same pattern. And directional deformation, it will also show the same pattern. The fixed support, there is minimum deformation, and the phase where the force and torsion is applied, there will be maximum deformation. Now, let's see some data. In total deformation, the maximum deformation will occur at the right extreme end, which is about 2.03 into 10 power minus 6 meter, and average will be in between in the both end. Equivalent elastic strain, the data is given in the results. Equivalent stress, maximum at the right end face and minimum at the middle, or we can say near to the fixed support. So this is all about our analysis part.